Alright, so let's go over what seems to be one of the most troublesome parts of Biochem 1 just because of the tedium, which is using Excel to do Hoff plots in this case, and the expertise you gain from this lesson you should be able to apply later on in the course when we're doing Michaelis-Menten plots and Lineweaver-Burke plots. You're going to have to come back to Excel, and it's the same skill set, so really try to become familiar with this interface, and of course if you have questions we're always available, but let's dive right in. So first off, um, I devised this data set. I used some manipulations and got a coherent looking set of numbers, so this looks kind of natural, but these numbers don't mean anything. Don't use these for the homework set. They're wrong. This is not what's on the homework. But at any rate, your first step is going to be just creating a table, a nice, neat table that you can present with your homework. And so what we do is we're gonna use this area here to the right. Let me see if it's showing. It is. So this area here to the right is what we're going to use, and we're just going to replicate what I did on the left. This is our end product. So the first thing we do is we scale up the columns. So we can do that. For example, if I want to make M larger, I just grab this barrier, drag it over however large I want it, and I drop, and now I have a more properly sized column. So I did that for these, and the other thing I did is I selected all of them that I'm going to use, the right number of columns and the right number of rows, and I went over here to this border tool, and I went down to all borders, and I inserted all borders, and now it has borders, whereas you can see here these are all just sort of, they don't have any. Then I'm going to create my headings. So we're going to have temperature in degrees Celsius. Don't need to retype this, but it's temperature in degrees C, temperature in degrees K, 1 over temperature in degrees K. And here I did 1 over temperature in degrees K times 1 over 10 to the negative 3. This is just a scaling thing to make the graph look a little bit different. I don't think it's necessary, but it's something that people like to do. It's something you can do if you're interested, so I thought I'd show it here. Then there's KEQ and LNKEQ. So let's go ahead and copy these headings and put them over here. And I like to fill in my headings and make it look more coherent. So if you want to do that, you'd select them all. You'd go over to the fill bucket and pick a nice color that you think is pretty. I will use salmon, because why not? Now we have our raw data, so you just type these numbers in. So you would have typed them in. I have them preset, so I'm not going to type them, but they're here. But I will show you how to convert to K. So you use the coefficient. So you go onto Google here and you type in Celsius to Kelvin conversion, and you'll see that it's 273.15 that you have to add if you didn't already know. So you would type in the equal sign, and this it sets Excel to execute a mathematical operation. The mathematical operation I want it to execute is P3, so P3 plus 273.15. And as you can see, it has added 273.15 to this temperature. And then all I do to apply it all the way down is I drag it at the bottom right corner down, and it has applied itself all the way down. And what that means is here it's P3, here it's P4, here it's P5, here it's P6. So it modifies which cell it's taking the variable from, and it runs the operation. And good. And so I'm going to do something similar for 1 over temperature. I'm going to hit equals 1 divided by, and here I'm going to put Q3. And you can see it's highlighted it. I hit enter, and I get 1 over 295. And if you want to check, equals 1 over 295, you did get the right value. So I click and I drag, and it's done. If I wanted to do this, it would be equals, so this would be Q3 times, you use a little asterisk, 1 over 10 to the negative 3 is what I used. So something went wrong the last time I did it. 1 over 0.001. Interesting. So let's ignore that for now. I'll come back to that. I should be able to copy this. There it goes. Oh, sorry, I put Q3, it's supposed to be R3. So yes, we put it equal to R3 over, times 1 over 0.001. That would give us the right number, and we drag and drop. So you can see it still gets me a little bit flustered sometimes, but that's okay. Now KEQ is another thing that was given. I just typed them in, so I'm going to copy them, put them over here, and then for ln KEQ, I'm going to do ln, and it is what I want it to be here. And it's going to be ln of T3. And I drag all the way down. Now I have all of my values. All right, so we're good to go to do our graphs. Now here's what we're going to do. Make sure that when we're copying and pasting the 1 over temperature and ln KEQ, which is what we're graphing in a Van Hoff plot, as you will know if you saw the last video, you need to put 1 over temperature on the left and ln KEQ on the right. For whatever reason in Excel, and I'm by no means the eminent scholar on Excel, whatever's on the left is the x-axis, and whatever is on the right is the y-axis. Yes, that is the case. So, what we do is we take 1 over temperature here. Let's just stick it somewhere out of the way. Make sure you... Now this has pasted the formulas, so it's pulling from the O series and doing the operation. What we want to do is go over here and we're going to use values and source formatting from the paste option, and that gives us the right looking thing. Do the same thing for ln KEQ. Values and source formatting, and so it gives us the values and the formatting. It does not run the equation again. That's important. Now we highlight the data, go to Insert, go to Scatter, click on this one on the left, Scatter with only markers. Put this somewhere nice and neat. Always be meticulous about your work. We are scientists after all. Then we're going to go over here to Layout. We're going to go to Chart Title. We're going to go to Above Chart, and we're going to type in, this is our, whatever you want to title it. If you want to title it LNK versus, you want to use that format, or just, I'm going to title it Van Hoff Example. Don't hit Enter. Just click off, otherwise that happens. Then I'm going to go to Axis Titles, Primary Horizontal Axis Title. I'm going to erase this, and I'm going to put 1 over temperature. And then we're going to go to axis titles, vertical axis title, rotated title. And you can use any title you want. If you prefer it to look differently, I'm going to put in ln of k. Click off. Now there's one more thing we have to do. We're going to go up here again. We went to if we went to Chart Tools, so Chart Tools, Layout, Trend Line, Linear Trend Line, then go back to Trend Line, go to More Trend Line Options, and look down here where it says Display Equation on Chart. We're going to click that, close it. Here's the equation we asked for, and we're going to stick it up here out of the way. Now this is a y equals mx plus b format equation. This is the Van Hoff equation, and let's just make sure that our values are correct. Here we have the x-axis scaled from 0.0029 to around 0.0035, and that's around what we have here. This maximum value is around 0.0034, so it went a bit over, and it went a bit under our lowest value. So that should be the x-axis, and it is. The y-axis should go from around 0.5 to around 2.5, and that's exactly what it does. So this is correct. So this is exactly how you create the plot. And if you wanted to do it like I did here for the scaled temperature values, you just use the scaled temperature values here on the left side, put L and KQ on the right, and you're good to go. Now, of course, we want to know how we get the various numbers that we need out of here. So let's take, for example, if we want to get delta H standard out of this, what we would do is take the m value, so the slope, which is, so it would be negative m, this is negative m. So positive m is going to be 4304.4. Let's just multiply that by the ideal gas constant, 0.08314. Sorry, supposed to put the equals operator in here. That would be our delta H. That would be our delta H. Now, if we've had forgotten to put it back in the positive, we know that we have negative delta H in the formula, so we need to look at positive delta H if we're just talking about delta H. We could do a similar thing for delta S using the B value, so that would be equal to, in this case, the B value over here, 15.07 times 0.008 314. This would be the delta S standard. Now, of course, using delta H and delta S for a given temperature, we can calculate delta G using delta G equals delta H minus T delta S. That equation, we would just plug it in. We would adjust temperature. Since we have 1 over temperature, we just put it back into temperature. And we can calculate delta G for all these values. And that's how you use a Van Hoff plot. So I hope that I didn't obscure anything with my head. I didn't. That's wonderful. And I hope this was of value. I know that this it creates a lot of questions because this is a biochemistry class, not an Excel class, but we have to accept that as we go into graduate school, professional school, the professional arena, we have to be able to graph, we have to be able to use Excel, and this is as good a time as any to learn it. So if you have any questions, please reach out to me or any member of the TA faculty or your course instructor. I hope this was of benefit, and I'll see you all in the workshops.